All right, we're back in week 9. This is going to be, we're going to talk about normalization some more. Again, effectively, normalization is what we've been doing the entire course, just kind of looking at it more from the, not so much from the technical side, just looking at the problems that can be caused and how we might go about finding solutions with our database design. So let's go ahead and look back over here. Let's go to the slide deck. And I have, if I can get this, hold on. Now, if we remember this little lesson here we had from the beginning of class where we had a table to track parents who volunteered to provide supplies for a classroom. The question is this table in the first normal form? And if not, how do we get it to the first normal form? Now, we got to remember first normal form, one thing we're looking out for is we do not want to have more than one piece of information in a square, in a box here. So each record and column needs to have one piece of information. So here we have supplies, and I've got multiple pieces of information here. They're all, comma separated, but effectively, no, they're not in first normal form because I've got multiple pieces of information in one spot. So how do we fix it? Well, we fix it by giving it its own table. And you notice we got a little note in here because multiple people can bring, just because it does, no one says you can't, more than one person can't bring more than one supply, or doesn't say that only a single supply can be given, or only if somebody brings crayons, he's the only person that can bring crayons. So we have is a many to many relationship here between these two. We created another table with all the comma separated values out by themselves, giving them all supply IDs. So this table is now nice first normal form, and we're in nice first normal form here. But in order to make this work, we do need to create an intermediate table that connects. That is a problem we've got to deal with, and this would be an intermediate table that would work. And you notice we even stuck in here a supply assign ID for the intermediate table to give it a primary key. Okay. Again, this point, a primary key is not totally required for a table like this for the intermediates, but it's always a good idea. So, but now we have our tables are all in first normal form. All right. Now let's look at exercise 2. We have a business with multiple store locations has created a table to track customers and their purchases. Is this table in second normal form? If not, what changes would you suggest to get it into second normal form? Okay, so we got a table here. Primary key is customer ID, store ID, store location, and total sales. When checking the tables in second normal form, you must first check if it's in first normal form. Since the table is not trying to store multiple values, it is in first normal form. So we've met that requirement. So we are 1NF. We're good. For the table to be in second normal form, each non-key field should require all fields from the primary key to determine its value. Okay, so what do we mean by that? Does total sale require both the customer ID and store ID to determine its value? Well, it does, yeah, because you had to have a customer make any purchase in a store to see what the sale was. Now, does store location require both customer ID and store ID? No. You can determine the location simply by the store ID. I know if it's store ID 1, it's Bridgewater. If it's store ID 2, it's Branchburg. If it's store ID 3, it is Newark. So these are not in second normal form because I've got a column that does not require everything in the primary key. So how would we fix this? We could leave the purchase table here with the dual primary key, customer and store ID, total sales. And we bring over here, we have a primary key, store ID, Bridgewater. Notice you can have two primary keys also be foreign keys, So it's a primary key and a foreign key, the store ID here. because it's part of the primary key, but it's also a foreign key to the primary key from this table now. So this brings us out into second normal form. Okay, so remember real quick, because I know this gets confusing. First normal form, we're concerned about stuff like this. Okay. Second normal form, this one is always tricky to look at, but you want to look at the fields that are not part of the primary key. Do they need the entire primary key to identify them? If not, then, they're not part of it. You need to move on to another solution. Exercise 3, you're running your own business, building and selling wooden furniture. You currently sell your items at various events such as craft fairs and town festivals. You built a database to keep track of your customers and the events you work and the items that you sell. One of your tables is called purchase details is shown. Is this in the third normal form? If not, what changes are we making? So, got purchase detail ID is our primary key. We have a customer ID, event ID, item description, quantity, and total sale. Okay, so I'm going to tell you right now, we already know looking through here, we are in first normal form. Okay, but this right here is not. This is second. This is not second normal form because item description, chair, table, and item IDs. I do not need the rest of this information. The primary key does nothing for me on this item description. That's one of the first things that jumps out at me. So we have to make sure we're in first and second normal form. Table is not trying to store multiple items. It is in first. Table has only one field for the primary key. It's in second. Okay, I kind of really don't like the way that's all being described in the book. Let's go ahead. Let's take a look. I got a great website here. I found Archetype. And this is a good description of the normal forms I want to kind of walk through. Maybe this will help better understand. So the first normal form is, again, we're looking here, cannot contain any multi-value or composited attribute. In other words, every single attribute in a table has to have an atomic value, singular value. So we got here, Walk to Remember, Harry Potter, all these, Goblet of Fire. So this one will be fine because that's just one. And then we got 3 movies here. So what we could do to put this into first normal form is literally this. So you notice we're not worried about primary keys right now. None of that, this doesn't matter. And I can duplicate everything. This is first normal form. So forget primary keys, all that, just right now, first normal form is simply atomic values. That's what we want to worry about, is making sure that each record and column intersection contains a single value. So this effectively is first normal form. Now, okay. Second normal form has to be in first normal form and has no what's called a partial dependency. Okay. And a non-key attribute can be used to determine the proper subset of a candidate key, and the relation said to be partial dependency. Let's see how this works to understand a little better. We have this table with classes taught, teacher ID, and the teacher's age. Teacher's age, which is a non-key attribute, as it cannot be used as an identifier. 2 people can have the same age. So this could not be a primary key because you can have duplicates of it, is dependent on the teacher ID. The teacher ID would not have duplicates because you can't have more than, each teacher ID is going to be unique to that teacher. So a proper subset of the candidate key. Therefore, this table has partial dependency and does not follow second normal form. So for this table at this point, we'd have to break this table up. So now we've got a teacher ID with age, and we have classes taught and who teaches, which teacher teaches them. What we effectively have right now, even though we haven't put the words here, is we've created tables now with primary keys, because now primary keys are a concern. Because we cannot have partial dependencies in second normal form. Again, up here, this first normal form, this is legit. This is perfectly fine. You don't need to have a primary key. This is, if this is all you want to do, this would be an effective table to have. But going to second normal form, again, we have to be meeting, we have to have the atomicity, or is that atomacy? The atomic, everything has to be an atomic singular value of one normal form. and then there's no partial dependencies. So at that point, you got to start thinking, when you hear partial dependencies, you got to start thinking of key attributes. So a primary key, you know. So now we've created it. We got the teacher ID is a good primary key because the IDs are unique, or the age doesn't matter. And then subjects, well, you know, obviously there could be more than one social sciences, but we'll just call it once at a time. So that's, you know, it's not a big deal. We'll call that our primary key here. Now the third normal form. The third normal form has to be in first, obviously, then in second. You know, if it's in second, then it is in first. And it has what's called no transitive dependencies for all the non-key attributes. Now, again, non-key attributes are any column that aren't the primary key. Okay. So we say to ourselves, if A equals B and B equals C are two functional dependencies, then A equals C is a transitive dependency. If a table has such an indirect dependency, it does not follow the third normal form. Okay, transitive dependency is what we're talking about here, and we'll talk about this more. Alternately, a relation with a functional dependency of A is equal to B is third normal form if one of these conditions are true. A is the superkey, and B is a prime attribute, i.e. B is part of the candidate key. Consider the following table. I have an employee ID, employee name, state, country, zip code. Okay. Primary key is employee ID. That's what we've decided. That's what's written here. Non-key attributes are the rest of these: employee name, state, country, and zip code. Employee zip is dependent on employee ID. Employee state and employee country are dependent on employee zip. Okay? Meaning, if all I know is the employee zip, I can derive the state and country, the zip code, you know, I can derive that. Thus, by definition of transitive dependency, employee state and employee country depend on employee ID because the employee zip depends on employee ID. So it's this transitive. So thus, by the definition of transitive dependency, employee state and employee country depend on employee ID. The table is therefore not in third normal form. We need to break it down to two tables. So now we have employee ID, the name, and the employee zip. Okay. This, of course, under the belief that, you know, then we have the zip codes here. Employee zip, state, and country. These are all derived dependency on here. Okay. So we're seeing what this means. Okay. If you could look like, you know, if you could imagine more columns here, like if I had a department they worked in and then I had their department boss's name, that would be another transitive thing, because while yes, by the employee, I should be able to look at your department and who your boss is via your employee ID. I could also look at the department and who the boss will be. So that would be a transitive ID. You know, that should be its own table to make it third normal form. So the difference between second and third normal form, the overview of the three normal forms, one thing sure, each form is stricter than the predecessor. For instance, two non-prime attributes are not dependent on the prime key, but a non-prime attribute can depend on another non-prime attribute. The third eliminates the possibility of non-prime attributes. Okay, I'm going to put a link to this page here on the table as well here. Let's go ahead, let's look back at let's go back to our slide deck here. I'm sorry, I'm kind of bouncing around here. I just really am not happy with the way they're teaching in this book, because the trick they try to go into is, you know, you can determine the item description based on the item ID value. That's more of a second normal. Really, technically, this would be the correct way you'd break this apart. But really, we should really be thinking back more towards how we looked at third normal. We really need to think about transitive properties. So And again, what's a transitive property here? Let's go ahead and let's put it in there. We want transitive. We don't want anything transitive. This is the issue with so transitive. So if A can determine B, so if I get the purchase ID, I could tell you which customer it was, what item they bought, and how many they bought. But can B or can C be derived from B? That's a problem. So C, when we go back to the earlier version here, if we imagine C being the item description here, can that be derived from the item ID? It can. It can be derived from the item ID without needing to know the primary key. The primary key is not necessary for this to be derived. So that's where your transitive issue comes in. You do not want transitive dependencies. You want everything to have to rely on the primary ID for it to make any sense. So it's one of the more, harder things to kind of understand what we're going over. But I really think I'm going to put the link to this website because I really like the way they cover it well. Okay. Thank you very much. I will see you guys in the next class.